All right, guys, I wanted to continue our study of looking at data and modeling data in different ways. Yesterday, we looked at how to find the five-number summary, and today I want to look at what that's used for. And the primary use of this is the box and whisker plot. Okay, we're going to talk about what this is and how to draw it, how to read it, and interpret it today. We're going to do more with this later on, but we're going to start with that. So, quick review. Let's go ahead and find the five-number summary for this set of data here. Okay, so again, our five-number summary is the minimum, first quartile, mean, third quartile, and maximum. And remember, what we're doing here is we're dividing the data into four parts. So I have this data set right here, 12, 13, 13, 15, 16, 18, 19, 31, 31, 33. So I'm gonna find the easy ones first again. Here's 12, and that's our lowest value. That's the minimum. Of course, I have this all in order. I typically will give them to you in order, smallest to largest. But remember, if they're not in order, you need to put them in order before you do any of this. Okay? So now that we have it in order, the minimum is 12. The maximum is this highest value, 33. Okay, then we have to find the median. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 values, which means the median is between the fifth and the sixth value. Okay, 10 divided by 2 is 5. Since it came out evenly, there's 5 on either side. So 1, 2, 3, 4, 5. So our median is going to be right between 16 and 18. And remember, to find that, we would average these two values, okay? So we're going to do 16 plus 18 divided by 2, that's 34, divided by 2, which equals 17. All right? Another way you could have done this is just think about 16 and 18. The average is halfway between, and 17 is right between those two numbers. So the median is 17. Okay? So now that we know the median, we have these five numbers to the left. We have these five numbers to the right. And we're going to find the median of each of those halves in order to get our first quartile and third quartile. So since there's an odd number, there is a value right in the middle. So right here, that is our first quartile, 13. And then notice right here, there's 5 values as well. The middle value here is 31. That's our third quartile, Q3. So I'm going to put that here, 31. Okay. And then finally, we have the IQR. The IQR, remember, is the range between the first quartile and the third quartile. Okay. So we're going to do that third quartile, 31, minus the first quartile, 13, and that will give us an IQR of 18. Okay, so that's what we did yesterday, and you practiced for homework. So how do we actually use this? All right, so the box and whisker plot, or box plot, you'll hear it referred to often, uses these 5 values. So you'll see I have a number line here first. We do want to have a number line, and we're going to put these 5 values. We're going to identify where they are on that number line, okay? But we're not going to put it right on. We're going to put it above the number line. So here's the minimum, 12. There's our minimum. Our maximum is over here at 33. I'm going to put it directly across, same height there. So that's our maximum. All right. Then I identify the median is at 17. And for this one, I'm going to actually put a bar going straight up and down. Okay. And then we have our quartiles at 13. There's 13. And over at 31. Okay, so there is 31. All right, now the reason why I drew this way is because we need to actually make the box and the whiskers. So the box actually connects these values. Okay, you'll notice here I've got, I can get this to cooperate here. All right. It goes from one end to the other, and I'll put one on the top and also one at the bottom. Okay. Move this up here. For some reason it doesn't like to start where I click. All right. So now you can see we have a box that's kind of separated into two pieces by the median. We'll talk about what that does in a little bit. But then we also have the whiskers, okay? So you'll notice right here, I notice that Q1 and Q3 make up the ends of the box. So that's these blue lines here, Q1, Q3. And you draw lines or whiskers from Q1 to the minimum. So I'm going to do that over here. There's my lower whisker, and from Q3 to the maximum. So up here is Q3. I'm going to draw my upper whisker going to the maximum. And that is our box and whisker plot. Okay, so you can actually see the 5-number summary: min, Q1, I'll go ahead and label those, Q1, the median, Q3, and the max. Okay, I'll label the median here as well. Okay, so that is our 5-number summary, and that is how we visualize it with our box plot. Okay, so how do we interpret a box plot? Well, here I have the same box plot, a little nicer format. But remember the board we were cutting into 4 pieces yesterday? That's how we identified we needed 5 values to define those 4 different pieces. But we also talked about how those 4 pieces represented 25% of the data each. Okay. In a board, if you're cutting it into 4 pieces, you're probably going to want to cut them into 4 equal pieces. But what we notice here is that the quarters of our data are not necessarily spread out the same way. Okay, for example, we can see right here, this is the first quarter of our data, and it's all crammed right here between 12 and 13, but that still represents 25% of our data. Then we have this from the first quartile to the median from 13 to 16. That represents 25% of our data. And then we have this very large range here from 16 to 31, the median to the third quartile. That also represents 25% of our data. And then you have the upper whisker here from 31 to 33. That range right there represents 25% of our data. Okay, so I know we had the data given originally up at the top, but let's assume that we didn't see that before. If I knew that that there were, let's say, just to be easy, 40 items of data in all, there would be 10 data points that would be between 12 and 13. There'd be 10 that would go from 13 to 16, somewhere in those values. There would be 10 more in this range from 16 to 31, and there'd be 10 more in this range from 31 to 33. Okay, however many you had as a total, you'd be able to figure out how many were in each range simply by taking 25%. Okay, so this box plot is really helpful in enabling us to visualize those quarters And we can explore different aspects of the situation, like we'll see in a sec, but also the spread of the data. So I want you to suppose that these numbers that we were given without context originally, let's suppose that they are the times that are recorded in a long distance race. Let's say it's a 3 mile race, okay? A 3 mile race. So our fastest person here finished 3 miles in 12 minutes. Now, I'm not sure, that's probably Olympic time, if anything. That's 3 4 minute miles, but that's really fast. Okay, but let's say the top 25% finished in this time frame. Okay, the fact that this left hand whisker is very short means that the fastest 25% finished pretty close together. They all finished within 1 minute of each other. And if you think about a race, if you've ever watched track and field, maybe the Olympics or something like that, you've seen this happen. You have this race, and you got some folks really close together at the finish line. Okay, then you've got some people, kind of a pack behind them that might finish a little bit slower. But then you have this right here, okay? The right half of the box between the median and Q3. Notice this is really spread out, okay? This is the group where that between 50 and 75%, they're not the fastest, they're not the slowest, but 25% of the racers or of the runners were really spread out, okay? Finishing anywhere from 16 minutes to 31 minutes. Okay, that's a large spread of time. Okay, and then again, we could even look at this down here, this last quartile. These are the stragglers. The last 25%, they're just glad they finished, it seems like. Okay, it took them between 31 and 33 minutes to finish. They really were never in contention of winning. They're just glad to finish the 3 miles and be done. Okay, um, so that's kind of how you can interpret this spread. Another thing, remember we talked about IQR. That's represented by this box. Okay, the IQR is this range. IQR was 31 minus 13, which was 18. Okay, that IQR represented the middle 50%. Okay, we'll talk about how that can be used actually, but in a moment. But that would be the middle 50%, where you don't have the fastest, we don't have the slowest, but the middle 50% are in that range right there. Okay. Now, another thing that you can use, I said we could explore other aspects of the situation. Suppose, again, we didn't have the original data, but we knew that there were 10 runners that ran in the race. Our original data had 10 data points, so that's how it was. How many people finished in less than 16 minutes? Well, if we look, 16 minutes is right here at the median. So I know that 50% fall below the median, okay? So that's going to be 50% of the 10 runners, which obviously gives us 5 runners, okay? So that's an example of how you could use this to help you tell some different things about the scenario. Okay. One other thing, I told you I'd mention this, but that middle 50%, the middle 50%, you'll see in a few years when you start looking at colleges, you might see different colleges or universities give you a range of ACT scores or SAT scores. And that middle 50% is often given as a typical result. Okay. It's not the absolute best. It's not the absolute worst, like in a race, the fastest or slowest, but it's the typical runner. The typical runner in this race would finish between 13 and 31 minutes. A university might give you the typical ACT score of someone that they accepted. For example, if they said that they admitted 50% of the students they admitted were in the 21 to 26 range on the ACT, that means, if you have, let's say you got a 23 on your ACT, you have a decent chance, at least a 50-50 chance of getting in at that college. If you scored a 29 or a 30, that means you probably have a great chance of getting in, getting accepted at that college. But if you only scored a 19, maybe you want to study a little bit more and it would be worth their investment to try to take the ACT or SAT again and try to get a little higher if you really want to get into that college. That is how we construct a box plot. It's how we interpret the box plot. And that is what we're going to be trying to do here in the practice. Is I'm going to be giving you different values, different box plots or data, and asking you to tell me a little bit about what's going on and interpreting that situation from the model that we're given.